Hey everyone, how's it going? We're going to continue our Pytorch convolutional neural network. We're going to build a LeNet. It's going to be great. We had some challenges at the end of last stream where we're trying to get data going through the model. I figured it out. It was only a few little bits and pieces, not a big issue. The input layer needed to be the right size. We were missing an extra dimension, so we added extra dimension there. We were also not inputting a batch with our input data. So we had to add an extra dimension for the batch because we've got one color channel and a 32 by 32 picture image. That's what we're doing there. Hey, Bra Machina, good to see you, Bra Machina. Welcome on in. We figured it out. Unknown, how's it going, Unknown? Good to see you. Thanks for saying hi. We're gonna build our LeNet today. We're gonna build the LeNet, which is a convolutional neural network. Very straightforward one, a simple one. Got a few filter layers, got a few dense layers. Here's our filters, and here's our linear dense layers. And we should be able to get a pretty good model using this approach. Pretty straightforward. This is what we're building right now. All right, so I do believe we've got it all set up. We just need to print it out and make sure that it's looking okay. Let's find out. Let's see if we can do it. I think we can. So where was that at here? So I did this, however, I didn't leave it completely in the right spot after fixing it here. Hey, Carlos Sylvia, good to see you. Welcome on in. Happy Tuesday. We're going to continue our CNN that we had a problem with at the end of last stream. We're going to fix it, though. We're going to fix it. So I believe we could go print out. Wait, are we already printing here? We're returning out already. Okay. And we are printing it here. Good. Okay. We don't need to use dot forward anymore because we updated our model to use the base model for neural network that allows you to use the dunder method. That's called, it's the double underscore method called callable or call. It allows you to execute this forward function automatically when you call the class name. So we don't have to call class. Hey, cheers, Stevens. You rock, man. Thank you, Carlos. Appreciate it. Good to have you here. Good feedback. I love that. All right, let's see if that runs. Let's see if it runs here. Oh, whoops. Wait. Oh, okay, there we go. Name the file wrong. All right, so we got a problem. Oh, no, I thought I fixed it. Wait. All right, let's see here. Return out. Okay. I thought we fixed it. Hello, sir. How's it going there? Fazenkind, good to see you. Welcome on in. Good to have you here. We're going to get ourselves a working convolutional neural network today. We've got enough time to do it. We do. We've got enough time. So we should be able to get it to work. Oh, it's not because I deleted something. Okay, there we go. We need to get the batch in there. So we've got the batch dimension here. Let's comment this so you can see what's going on. All right, so we've got our batch, our color channels, and our width, and our height, right? So that would be B equals batch. Soki, good to see you. My courses started. Let's go. Last week. Oh, it's the start of last week. Let's go. Nice. Very good to hear it. That sounds exciting. Is it the right time? Yeah, I guess it's the right time. And see, it's going to be the color. So like red, green, blue, right? Red, green, blue, or alpha, or X, Y, Z, right? You could have any color that you would have 100 channels if you wanted to. Did you add your X-ray channels? Did you add your infrared channels? Whatever color dimensions that you want to put into your data, you can. In this case, our color is going to be one color, I believe. It's just grayscale, as far as I know. It's a grayscale color. That's what we're going to be doing. I'm pretty sure that's the plan. All right. We got computer vision. Yeah, let's do it. Hope it's not just all math. Well, I don't know. It technically is all math, as far as I can tell. You might be able to be using some frameworks. I'm very curious what you'll end up using. You might end up using Pytorch. You might build your own, which will be maybe some challenge there. If you have to build your own, I think that's a little bit much to have to burden anyone with, to have to build their own. Color, we have width equals width. We've got height. Also, we got height here. Height. H-E-I-G-H-T, H-E-I-G-H-T. Height. Height. Is it height? Is that a word? Is that a word? I don't think. That makes me happy. Is that a word? I don't think it is height. Oh, wait. It might actually be. Wait. Hey, Carmine. Good to see you. Welcome on in. Height is a dialect variant of the colloquial spelling of the word height, meaning the measurement from base to top. Okay. So it is height, not height. Although Google is saying that it's okay to use height, even though it's outdated. That made me happy for a second. So let's just say height. There we go. Sir, I just got a question. All right. Fiazan, what do you got? Have started to learn machine learning. Ooh, there we go. And I have like taken a step back and I like reverse all the mathematics and topics. Okay. So that math, do not go hard with this to be good. Yes, that's correct. Okay. So you don't need to go hard on the math. You don't. You can just use the frameworks and lean on the frameworks and have them do the majority of the work for you. And you'll be able to leverage any sort of technique that you want. Really, you can. And especially now that you've got AI as the guide, it can help you along the way and build out, or even you can follow along and learn with the AI directly. Because it will take you 2 months to reverse everything in maths. It will. It will. There's a lot. There's not a little bit. There's a lot. And what's kind of surprising is it's very forgiving and very non-forgiving at the same time. It's going to give you a whole bunch of challenges. Like, why isn't it working? Oh, why is it kind of working? Because it's forgiving in a not good way. It's forgiving in a way that allows it to kind of work, but you don't know that it could work way better if you uncleared some things. For example, I built several neural networks from scratch and I used bias in the wrong approach. You can apply bias to your model in various different directions. You can either have a bias feature that is included to prevent a minimization of your data. You can do a lot of different things. Bro, what are we working on? Joseph, hey, good to see you. Joseph. We are going to be building a convolutional neural network today. We're becoming Pytorch experts. Join me. We're going to go through every Pytorch tutorial that's available on the Pytorch website, and then we're going to start building some models. Sorry. Hey, Flo, how's it going? Flo, good to see you. Is there any vulnerability you expose yourself by installing libraries from pip? Yeah. Yep. How do you know no one's smuggling malware or stuff into Numpy or any other lib? Well, it's open source. So part of the open source concept is that it's auditable. A lot of corporations depend on these installation package management flow, right? They're going to be, including my company, we use a lot of Python, we use a lot of Rust, we use a lot of other languages, JavaScript. We need to make sure that our workflow is secure. And so we pay a lot of money to add extra security for scanning. And we add that scanning across all those public repositories. So you get sort of a consequence of benefit from industry being able to trust those systems. Yeah. Joseph, thank you for subscribing. Appreciate it. Happy to have you here. Wow, subscribe. Nice. Very nice. Yeah, so you basically can trust package management systems. To the most part, yes, they do have vulnerabilities and they do get into the chain. The good news is we find them, we fix them. Bye for now. Meet you next time. Sounds good? It's very late here. Well, I'm glad you stopped then by. I see. That's awesome. Nice, Flo. Great to hear it. All right, let's get on to our LeNet. So let's see if it runs now. Let's see if it runs without crashing. All right, so far so good. Let's go to the next level. Broken here. Did we fix this part right here? We might have. We might have fixed that part. Let's try it. Did we fix it? Yes, we fixed it. Okay, thank goodness. I was worried about that. I'm like, it might not be working. All right, so can we go to layer 2 now? Can we do layer 2? We should be able to. Once it gets past the first layer, we're good. And then the final layer. Do we have linear layer 3? All right, let's do that. Linear layer 3. There we go. So that's going to give us a classification of 10 possible classes. So we'll be able to train this model on 10 possible classes. And I would like to say self.classes equals 10. So that way we have it set up early. Thank you for the hearts, you guys. Appreciate it. The little floaty heart icons there. You got to click those on the screen. And I see them. I see them when you do it. They show up right there. They show up on my screen. I can see them. Yep, you're right there. Yep, you see them right there. Right there. You see the floaty heart icons right there. So good to have you guys here. We're going to be building convolutional neural net today. Today is the day that we are going to make sure that we get. I mean, technically, we just finished it. We're gonna pull data through it though. We'll run data through it. We'll train it, and we'll see how good the model is. We'll run it on an accelerator, so that way we don't have to wait 100 years to wait for it to train. So it's gonna go fast. It'll go fast. Think for the party poppers, you guys. Let's get into it. Hi, how's it going there? Was it Devotion? Devotional Talks. Good to see you, Devotional Talks. Thank you for saying hi. All right, let's get back to our coding here. Thank you for the party poppers. Appreciate it. All right, do we have all our number classes out there? Yeah, we got everything good there? Okay, so we fixed that. That's good now. That's all clean. Hey, there we go. Nice and easy. So we're going to be fitting data based on this format. As you can see here, kind of zooming in a little bit. We have our batch size, our color channels. We're going to have one color, grayscale, right? The width and height. There we go. Let's do it. Let's do it. So I think we're good to go. So we don't need, this should print a much smaller screen now. Yeah, there it goes right here. Hey, how's it going there? Who's that? Who's that? Donnie Yor, thank you for subscribing. Appreciate it. Is this live stream vertical only? So here's the deal. We have been working with YouTube. We're talking with YouTube. They say that at some point they're going to be able to support dual streaming in a way that doesn't affect stats. So yes, today we could do dual streaming. I do have good news for you though. We are on Twitch. Someday though, we might go 100% on YouTube. So we do have the horizontal stream right here. And that's on Twitch. I'll show you guys where that is, just in case you want that. Although we are here for YouTube. We are here for YouTube. So you go twitch.com/Stephen Elby. There you go. Stephen LB. A little bit of echo there. There you go. So if you want, that's over there on the Twitch. So eventually we will be getting on YouTube as well for a dual stream. They said specifically there's a known bug on YouTube right now. They're like, yeah, we know about it. We're going to fix it eventually. Stephen LB. Yeah, Sergio, good to see you. Sergio, Montana, good to have you. All right, let's continue on with our tutorial. We're gonna make it work. We're gonna make it work. Okay. Inherits, blah, blah, blah. Did we get this? Inits, yes. A model forward function. We know about that. We did all the things. We initialize. 32, black and white image. We don't call forward directly because you don't need to. If you want to, you can though. You can. Surge. Oh, surge. Okay, surge. Gotcha. Twitch doesn't seem horizontal. It seems pretty horizontal, doesn't it? Wait, is it not? Hold on. It is very horizontal. Yeah, it's horizontal. What are we talking about? That's horizontal. Hey, my guy, what are we doing right now? Hey, GCA. We're going to become Pytorch experts. We're going through every single Pytorch tutorial. We're in part 2. We did last week. We went through all the initial parts of Pytorch. It was saying that it was like the basics. It wasn't basic. Just kidding, bro. I was wondering about that. I was wondering. No worries. I was wondering. So let's print the shape. Oh, we don't have to print the shape. We already know what the shape is there. It's going to be 1, 32, 32. Okay. Output.shape, blah, blah, blah. Looks all like this. And we get our classifications on the raw output. Awesome. Yeah, I'm excited about this. We're getting good, you guys. We're getting good. That's the idea. Join me. Let's become experts together. We're going to know every single method available. And we're going to learn them together. Live on stream, you guys. That's the plan. So first we initiate the LeNet class. We print out net object. We called our LeNet. We just called it LeNet. You can call it whatever you want. So we called it LeNet like that. And let's keep on going. Let's keep going. Below that we create input data representing a 32 by 32 image with one color channel. Now, just to let you know what that color channel looks like, let's take a peek. Let's take a little look at that. Let's take a look. We should be able to see the full image here. I'm just going to print the entire thing out. Let's print R like this. So this is what a picture looks like right here. Right here, you guys. Right here. Here's the picture. There you go. And it is a color channel. So you see sort of floating point numbers, right? You see a lot of floating point numbers. Paulus. Hey, thank you for subscribing, Paulus. Welcome on in. Good to have you here. You joined the right channel for software engineering. We're becoming AI experts. Join me together. Let's do this. We're going to read through all the Pytorch documentation. We're going to go through every tutorial. So this is a batch of 16, one color channel, 32 by 32 image. Since we're only using one image, we're going to create a batch of one. Whoa. Okay, got it. Yeah. So we could do 16 right now if we wanted to. Yo, am I late? Hey, McPeace, good to see ya. Sup, everyone? Welcome on in. You are on time. We are just getting started with part 2. We're creating a CNN. We're going to be training and loading our data next. Let's load our data. Let's do it. Let's load our data. Thank you for the hearts, you guys. Appreciate it. All right. What is this part here? Inline? What is this? I've never seen this. What is this? Is this a thing? That can't be real. That's not a thing. That's not a thing in Python, is it? I've been using Python since almost it came out. That's not a thing, right? You can't do anything with that. What is that? Is this? It's just a comment. It's just a comment. Why do they have this here and why is it highlighted in yellow? What is that? Is that just some it's gotta be some like leftover weirdness is what it's gotta be. It's gotta be, right? Where'd that go? Here it is right here. Is that for Jupyter Notebook? Oh, is it? Oh, got it. Okay. See, I don't use any of those notebooks. Hey, do you remember me? Kushmax. Am I saying her name right? Maybe a smidge. If you chat more, my neurons, you'll trigger my neurons. Yeah, yes. Hey, nice. Very nice. Good to hear it. Okay, let's keep going. Let's get into it. So you say this is for Jupyter Notebook? Okay. I'm not familiar. I know what it is. I've used it before. I like to stay in my little terminal window. That's where I like that. Okay. Do we have transforms? Okay, so this is what I'm familiar. All right, so import torch vision. So we got torch. All right, do import torch vision. We're gonna load the data, right? Torch transformers. Import torch vision dot is it torch transformers like that? As transformers or transformers. There we go. And we're going to be, I believe this is going to help us decode images is what we're going to do. So we're going to load the data image, raw data images, like the PNG files, right? And then we're going to transform them and prepare them for the AI model because you can't just put raw data into an AI model. You have to scale it because AI models like input data between 0 and 1 or -1 to +1 in that range, -1, +1, right? If you have anything bigger, it'll still work. It's just that now you're starting to stretch the gradients or stretch your potential throughput to hit values that is not going to work well against activations. So you got to be careful. It can do vanishing gradients. You can do vanishing gradient problems, especially if you have activations. And if your input data is too big, then your model can't learn very well. So that's why it's really good to scale it. Which is why we have this line right here, the transformers. Okay, so we're gonna do a composition. We're gonna normalize the pixels. And this is just going to squash those colored between 0 and 255 down to a very specific range, which kind of looks like a grayscale range is what we're looking at. So we've got color images and we're gonna convert them to grayscale. Yes, normalizing is important or we face gradient explosions. Yeah, GCA, good to see you. You know it. Awesome. Good to have you here, GCA. Thank you. Keep commenting on any of the reasons and other things like that. You'll add more as we're learning together. It helps us together as we're learning. GCA, thank you. Specify 2 transformers. So we're going to have a composition transform. We're going to convert it to a tensor and then we're going to grayscale it, I believe. Let's find out what the normalize is going to do. Adjust the values of the tensor so that the average is 0 and their standard deviation is 1. So we're shrinking that down to 0 to 255, down to 0 and 1, right? A little teeny tiny. So that way, most activation functions have the strongest gradients around x0. Oh, hey, look at that. So we know what we're talking about here, right? It's all about the activation functions. That's why we want the numbers between 0 and 1. So centering our data around here can speed up learning. The values passed to the transformers means first the tuple and the standard deviation, second tuple of the RGB values in the image dataset. You can calculate these values yourself by running these few lines of code. All right, let's do it. We're going to, where's the composition? All right, so we're gonna do this transform here. Let's do this transform. We could do that here. I kind of want to do it right here. Self.transform equals was a transformer. Transformers.compose. Compose like that. Let's go to the next. Okay. And I believe it's an array. Yeah, so we're going to do an array here. And then we'll end the array like that. I like doing it this way. And this will be a two tensor. Transforms.to tensor. Like that. And then we're going to have a transformers.normalize. And we have a couple of values here, I believe. What are the exact values? What are we doing? Hey, Doge Multiverse, good to see ya! Doge Multiverse, we are creating a convolutional neural network, and we're starting to prepare our AI model that we wrote yesterday. This is a LeNet. It's a LeNet. Whatever a LeNet is! It's going to be able to correctly classify a large number of images. I like that music. Yeah, what's the name of it? This is one of my favorite songs. In the YouTube studio, it's from Jeremy Blake, called Heaven and Hell. It's one of my favorites. It's Creative Commons. It's free. It's license free. It means I can stream it on YouTube, and we don't have to worry about any of the license problems, right? Copyright challenges like that. So cool. Gotta go. All right. Doge Multiverse, thank you for stopping by. Good to have you here. All right, one moment. My alarm's going off. I'll BRB, really like about 20 seconds. BRB. All right, I told you, less than 20 seconds. Thank you for the hearts, you guys, appreciate it. All right, good to have you here. Let's keep building our convolutional neural network. Let's build over what the values are going to be. A whole bunch of numbers. Do we really want to type those numbers in, or should I copy paste? Oh, heaven and what? Sorry. I will paste it here to you in chat. Here we go. Copy and paste that. Here we go. All right. So this is YouTube Studio Music. Here, let's just so you can see what I'm looking at here. YouTube Studio Music called Heaven and Hell by Jeremy Blake. There you go. Can I edit that? No, that's fine. So let me type that better. There you go. Thanks, man. Yeah, you're welcome. Alexander, absolutely happy to help. Let's copy and paste these numbers because I don't want to type them in. We don't need to spend time typing these numbers in. They're just normalization numbers for 3 color channels converting down to 1 color channel, I believe. And I was expecting that this is going to be... Okay, so the values passed through the transforms are the means, first tuple, and the standard deviation, the second tuple, of the red, green, blue values of the images in the dataset. You can calculate these yourself. All right, so this should transforms.compose. Yes, exactly. I believe this is just going to convert our red, green, blue to 1 channel. I'm pretty sure. Let's find out, shall we? We will do this. Train set. La 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 la. Torch stack sample. What's this part here? Okay. Utils data concat dataset. Compose tensor. Let me just read through this real quick. Okay. So we're going to download this dataset here. All right. So this is going to be the dataset that we're going to load. This will be the train data. And we are going to transform that. Is this transform? Okay. Okay, let's do this. All right. Let's grab this dataset. All right. Import our torch.utils.data. And this is going to be from, I believe. From import concat dataset. Okay. This is going to give us access to the test data, which is really great. The full data set of just a bunch of images, which is really nice. Most frameworks they don't include really nice utilities like this that give you automatic access to data. Otherwise, we just have to find a zip file somewhere and grab it and download it. And I hope it works. Love all your work and what you do for the community. Hey, thank you, Darren. Appreciate it. Darren Hoyer. If the tokenizer works, but responses are not useful, could training be the issue? Yeah, it could be. Typo line number 17. Oh, we got a typo. Oh, right here. Compose. Did I type that right? Line number 17 right here. Transform equals transformers. Compose. Is this wrong right here? Did I spell this wrong? Compose? That seems right. Transforms. Oh, did I type that? Transformers. Oh, is this part right here saying? Transform. I'm looking, Jose. I'm looking. Okay, Joseph. All right, Joseph. Transformers. That looks fine, doesn't it? Wait, are you being weird? Did you ever have a developed something with the Flutter framework? Oh, I've used Flutter before to make an SDK for my API. That's as far as I've gotten. I just learned that tokens are words. Yeah, they are, aren't they? They're words, or they're partial words. They could be partial words, right? Or they could, for the most part, right? They're usually coming through embeddings, so that way you can get more meaning, semantic meaning, in relationship to other words. So that's a big part of it. Oh, transforms.compose. Is this not correct? Am I doing it wrong? All right, I'm going to try running it. Oh, yeah, you're right. No module named transformer. Okay, so transformed. Thank you. Now we figured it out. All right. It only took us a few seconds there. Thank you. Thank you for that. Appreciate it. Okay, look at that. Fixed. All right, there we go. Thank you, you guys. Keep paying attention. We might make more mistakes like this a few times today, because usually that's how it works. Mark Lemon, good to see you. What's up, brother? Welcome on in. We're going to continue our convolutional neural network. We're getting close. We're building it out. Now we're going to load the data now. We're going to load the data into the model. Thank you for the hearts, you guys. Appreciate it. Thank you for the heart reactions. I see those floating heart icons there. All right, let's keep going. Appreciate it. Okay, so now it should be good. All right, now we're good. No errors. Oh no! Wait. Oh, we got another problem. All right, we know where that is. No worries, you guys. Right here. Wah-pa-pa. There we go. There, better now. Now it's gonna work, right? Now it's gonna work. Yay! There we go. Okay. Thank you, you guys. Appreciate it. That's awesome. Okay. All right. Let's load our concat data set here. Where is this? We're gonna wait. Are we gonna use this ever? Hold on. Oh, stack all train images together into a tensor of a shape. Oh, wait. It wants us to load all 50,000 images in one giant batch? Really? I suppose we could. Why does it want us to do that? This is really weird. It's unexpected. We don't need to do that. I suppose get the mean of each channel, get the standard deviation of each channel. Okay, for what purpose? What are we gonna do with that? Are we gonna use that, or are we just gonna do it for fun? Is there any purpose for that, or did it just like, you could do this if you want to? No reason why. Transformers aren't AI, they're totally sentient mechanical beings. Ah, Carlos. Are they? Do they have consciousness? Do you think they have consciousness? Are we gonna be at that point where we've created consciousness in machines? I feel like we might be a few stages away from that, maybe. Maybe just a few stages away. Right now, they're really good statistical next word generators, right? Generative AI. We could do this if we want to. Why, though? Why? Oh, is this where we got our values from above? Right here. Oh, it's explaining it to us without telling us the details. There are many transforms available, including cropping, centering, rotation, and reflection. Next, we'll create a Cifaro 10 dataset, which is a bunch of 32 by 32 color images. Do you recommend to read Mathematics for Machine Learning by Mark Peter? I don't know. Would you want to read a book? Do you really want to read a book? Here's my question to you. Do you want to read a book? No. No, you don't. No, you don't. My recommendation is just jump straight into the code and start messing with it. That's what I did. And you'll start building up your knowledge more rapidly, rather than just reading a book. You will, I promise. Why don't we train AGI, given that meaning of AGI according to human? Artificial general intelligence, right? We are trying. We, as in the collective humans. Thank you for the hearts, you guys. Appreciate it. Yeah, we are. We're trying it right now. We're trying to replicate a full human in a box. We're trying to say, hey, AI, be real. Be real. We want you to be real. Why aren't you alive yet? It's not alive. It's a good trick right now. No, I think I can start working faster. Will not understand what's going on. That's okay. That's okay. Even if you read the book, you won't understand either. It won't make sense. I've done this. It's a trick. It's a trick. Go back. Don't let them trick you into reading the book. Just start writing the code. Hey, Coltman, good to see you. Thank you for saying hi. I mean, if you really want to read the book, don't let me stop you. Lead your own ambitions wherever they take you. Do it. Go in the direction you want to go. I'm just saying, reading the book is really boring. That's what I say. Maybe. All right. Thank you for the reactions, you guys. Appreciate it. Karthix just started a project. I have zero experience, or the field I'm working in. Literally learning everything as I go. Can confirm this. Karthix. Cathix. Yes. You're doing it the right way. You're doing it the right way. It's going to take you down the path of actually becoming an expert, because you're going to build it. You're going to run into errors. You're going to try, and you're going to learn this process of debugging. Right? You're going to learn this process of debugging. You don't get that from a book. A book is going to tell you how to do it right the first time. And you're going to miss out on all the mistakes that you can learn. The mistakes are critical foundation of a knowledge you are going to miss completely by reading a book. That's why reading books are pointless. Don't do it. Maybe there's like 1 point to reading a book, but there's a million points just to diving into the code directly. Right now is generating videos. I don't understand what weights are. Laurel, tensors, and so on. Weights are really easy. They're just a number. I'll show you. Here you go. This is a weight right here. See this right here? It's a weight. This number right here, that's a weight. It's just a number. It's also a coefficient. It's also called the parameters. There's so many names for all these numbers. It's just a number. You're right. Mistakes make sense. Yeah, they sure do. They do. You got to make those mistakes. Otherwise, you're going to miss out on a bucket amount of knowledge by just reading the book. Man, it must be so distracting, frustrating reading the chats and trying to code. I love your work, bro. Hey, GCA, it's perfectly fine. That's why we're here. Because of you guys. Distract away. All right, I want to print out the test data. So now we've got our transform, got our classes, our density, our layers. Let me move the transform though down to up here. So transform comes first. So this is going to be at the first part of our layer. We do the transform first. It is the encoding or vectorization. It's like the vectorize to 0 and 1 range. That's what we want to do right there. Hey, Red the Saver, good to see you. Welcome on in. Happy Tuesday. Cathix, have you heard about the Meta's Veal JEPA models? A little while ago, yes, I did. Have not looked into it. Tell me about what you're thinking. Cathix, about those models. Thank you for the reactions, you guys. All right, let's get back into it. Thank you for the floaty heart icons. I like seeing those floaty hearts show up there. Makes me feel good. Okay, and the party poppers. The party poppers too, and the hearts. Okay, let's keep going. All right, let's pop back over to the right window. There we go. Okay. Yeah. All right. Party poppers, you guys. Let's run our train. So this is neat. This part I didn't understand until I recognized the numbers. This is where we got the information about how we're going to transform our input data. So that way it's perfectly uniform. How we normalize the data. Right? Because you can get numbers between 0 and 255. However, most images don't go that full color range. So you can see that it's mostly there, but it's not completely. It's not completely. True Banderlog. Hey, True Banderlog, thank you for subscribing. Appreciate it. Welcome on in. You joined the right channel for software engineering. We're becoming software experts with Pytorch. We're going to be Pytorch experts, which means we're going to know how to build any kind of AI in the entire world. KY, thank you for subscribing as well. Appreciate it, KY. Good to have you here. Happy Tuesday. Hey, Fizzy, good to see you. Thank you for saying hi. Welcome on in. Let's do this really quick. I want to do this part real quick. So let's load in our data. Let's load in our data here. Where is this? I want to go here. All right. We'll load in our data. Hey, you did come across the new Gemini Embeddings 2 model. Oh, multimodal embeddings are dope. The Gemini Embedding 2 model. Is it embedding? It's multimodal embedding? Really? Oh, GCA, thank you for saying this. Actually really critical to something I'm working on right now, so I appreciate it. Oh, GCA, thank you. Thank you, thank you, thank you. Okay, nice. All right, now I'm excited. All right, so I've got something to do after stream. After stream, you guys. You came back. Hey, good. Thank you for coming back. Appreciate it. Good to have you here. So we're going to go our training data. So let me get this back to where it needs to be here. All right, good to go, good to go. Okay. So we're going to go train set. Train set equals, we're going to torch vision, right? Torch vision dot, what's the YouTube survey music doing here? It's Creative Commons music that allows me to stream it while you're watching right here in the YouTube studio. It allows me to do that without having any copyright issues. That's what. Let's do this part right here. I want to remember it. Datasets dot CIF AR10. Okay. And we're going to say root equals .forth data. And then we're going to say download equals true. And we're going to say train equals true. And was there something else? Oh, transform. Transform equals, did we do this? All right, we got to do a temporary transform. You're thinking of starting a web development for other people what do you think is a good price range? Depends on the businesses that you're targeting, right? Your target market. Are you going to go after very large businesses, mid-cap businesses, small businesses? You want to put your price range in something that's going to be favorable to them while they still get a good ROI. And you need to relate your messaging from a marketing perspective on how you're going to approach that business from an industry. You need to represent expertise and how you're going to present them online. There you go. So that's like a price range would be dependent. So if it's a smaller business, you could do say something like between 100 and 500 per month, something like that. If it's a small business. If it's a medium-sized business, you go $10,000 to $50,000 per year, right? So those are the ranges. It's more work though. It's more work. Thank you for the hearts, you guys. What are your thoughts on ArcCraft? What is that? What's ArcCraft? I was thinking of installing it on a KDE Plasma on Fedora. I don't know what ArcCraft is. Is that a variant on Linux? Is it a Linux distribution? Thank you for the hearts, guys. Not sure how you feel about having semantic embeddings as a methodology of vectorization. Seems stronger overall. Over time, lots of room for misinterpretation if trained incorrectly. Cathix, that's a good point. We could do some embeddings on this. We could get some pre-trained embedding, which is going to give us a different set of vectors of KDE. I don't know what ArcCraft is. What is ArcCraft? Like, you mean to get an offer, then I sell the site the way they want. Yes. No, like, I mean I get an offer, then I sell the site. I don't quite understand. Arch Linux branch. Oh, got it. Okay. Oh, Arch Linux. Well, that's just a variant. All I can say is use Linux. Use Linux, might as well. I've used a lot of Linux. I use Linux every day. I use it on servers, and I'm currently running a Unix variant, which is Darwin, right? I'm running Darwin right now. This is the screen you see. We're running Darwin, right? Uname right here. Darwin right there on the screen. I don't know if you can see it. It says Darwin right there on the screen. All right, let's get going, you guys. So we need more stuff. We need more stuff. We need the transform here. Let's do the compose. Let's just do a quick copy paste on this. So we're going to grab that. And we're going to put this here. There we go. Transform. Okay. Bring it over there. And we are going to set that here. Oh, is there an extra comma there? That is perfectly fine. Because it's Python and you can do it. Transform equals transform. There we go. Yes. There we go. Okay, perfect. Nope. Yep. What with the too many copy and pastes. Thank you for the hearts, you guys. Appreciate it. I meant my opinion for the VLJEPA model. Oh. Oh. Oh, got it. At least from what I understand. Okay, got it. So that's your feeling on the JEPA model and how they use an embedding on the multimodal embedding for the vectorization methodology. Seems stronger overall. Well, that's that's how all the large language models are working now, right? Including the multimodal ones. When you have the vectorization phase, you're going to be running your input data through an embedding, right? And that's going to give them extra semantic meaning to understand about different kinds of images, right? When you're building an embedding layer, what you do is it's called triple loss, right? It's the triple loss. You can create your own embedding model, which is separate, and you have something that's somewhat similar and something that's slightly different. Two different pictures, like a cat and a dog or something. They're both animals, but they're different animals, right? So you got two pictures, and then you put those through the model, and then you get the output from those two items, and that is your third element. And then you apply that into a triple loss function, and you use that in your back propagation to create your embedding model. If you wanted to build your own embedding model, that's the trick that they use. That's how they do it. You had a question? Do you know why everyone new in this thing is fond of Kali Linux? Oh yeah, I know why Kali Linux is famous. Because there's a show called Mr. Robot. It was in hacker TV series, Mr. Robot. They used Kali Linux in that TV series. It was really neat. And they use it because it's a common hacker's Linux operating system. It's just a distribution that comes pre-installed with a whole bunch of Metasploit tools for what you call penetration testing and nefarious means like Wi-Fi takeovers and a couple other things like that. You have so much fun to learn. Yeah, so much to learn. Dear goodness. I know, right? There's a lot to learn, you guys. We've been doing this for decades. So happy to tell you everything that's worked for me over the years. All right, is this good enough? I'm going to make this pretty here real quick so I can see it a little bit better. There we go. Yeah, ba-ba. All right, there we go. Comma, trailing comma, you guys. All right, so that should allow me to load the data real quick. Let me double check that I didn't typo anything. There, now it's loading the data. There we go. Love to get the free Wi-Fi from my neighbors. Yeah, there, yeah, exactly. A line should be passed. Oh, D-type. Do I need a D-type? Numpy. Oh, I don't want to use Numpy. I want to use Pytorch. Numpy 2.4 deprecated. Personal question. Have you always had this kind of energy, positive, or did you learn over time? I think I've always kind of had this excitement, energy, maybe, and it grew. It grew because as I got more technology, there's more things to get excited about in software engineering, I think. Sada Hussein, thank you for subscribing. Welcome on in. Good to have you here. Happy Tuesday. We're going to become Pytorch experts, you guys. Join me together. We're going to do this together. We're going to become Pytorch experts. We're going to go through every single tutorial live on this stream. We did part 1 last week. We did really good. Now we're doing part 2. We're making it happen. All right, loaded the training data set. Let me reload that and see if that looks good. All right, looks good. Visible deprecation warning, D-type. A line should be passed as a Python NumPy Boolean. Got a line 0. Did you mean to pass a tuple? What line? What line? Kafar. Okay, so this is a data set loading problem. I don't think I have much control over this. I don't like that I don't have control over it. I want to fix it right now. How did you manage that when you were working in 9 to 5, being asked to do something you didn't really care to do? Oh, yes. So it's called moonlighting, right? Moonlighting. There you go. It means you just have to work at night. That's what it means. You got to work at nighttime too. Modern Wi-Fi have a good encryption. Good luck breaking in. Oh yeah. So there are some some tricks. Yeah, that's a good point. Modern Wi-Fi, very strong. Very strong. If you're on the same network, and there are some things that are not completely encrypted. You can find some data in the packets, I believe. You could find some data in the packets. So, yeah, there might be some fun things in there. There's some data that's not fully encrypted that you can get access to. I created my own simple personal memory system using hashtags and keywords instead of complex vector embeddings. Think of it as a smart filing cabinet for your AI conversations and memories. Hey, AI with Vire, you're doing it proper, because similarity search doesn't always give you the best results. If you're going to be searching for things, RVI, reverse indexing, on keyword search often can give you a far superior result, especially if it's specific data that you're working with. You know it. You did a really good job with that. Good job. I say you did a good job. Okay, let's get back over here. Let us run this data through our standard std equals. Let's do this in the mean as well. So let's do dimension 0, 2, and 3, which is going to be, we got the batch data. Oh, we got to stack the data first. Do we really have to stack the data? Okay, I suppose. All right, let's stack all the data. Let's do this. All right. X equals torch.stack. It's going to basically put every image into, I think it's just going to batch it all up is what it's going to do. Thanks. Yeah, you did it. You're doing it right. That's actually, and you can also, if you want, you could also pair it with some vector searching, and then you can sort of do a weighting. So you could weight like maybe 70% or 80% on your keyword search, and then add a little bit of weight from the similarity search as well. So you can have multiple indexes working together in tandem, so you can get slightly improved results depending on the user search parameter. Okay, so let's stack our samples. Where's our samples coming from? Concat dataset. Okay, so we're going to concat. And this is going to be our train set, like that, I believe, right? There we go. We'll say SN S4SN. Engineer in progress. Thank you for subscribing. Appreciate it. Hey, you're doing the right channel. This is about engineering, right? S4SN. I believe that's it right there. Oh, we have to do something different. Yeah. So the 0. Okay, we're gonna grab 0. And we don't want to print that because there's a lot of data. If we printed X right now, our screen would explode. You actually do chroma DB and Lance DB. You were going to say that next. Oh, nice. Okay. Fantastic. Ayo, what it do? Hey, David Bailey, good to see you. We're currently building some understanding about Pytorch. We're learning everything in Pytorch. We're going to learn the origin of these fun numbers right here. You see these numbers right here on screen, which I'm going to make a little bit more obvious now. Let's pull this in here. There we go. Okay, and then we pull this over here. I'm making it a little bit prettier so we can see it easier. Comma. There we go. Excellent. Okay, so these numbers, these sets of numbers here, we're gonna figure out where we got that from. How do we get these numbers? Are all of your streams saved? Yes, they are, Guru Teha. They sure are, Guru Teha. Good to see you. Welcome back. All right. They are. You can see them here. So you go Steven on YouTube, and you click live, and you see right here. You get to every single one. And how many Pytorch have we done? So coding without AI. Here we go. Pytorch right here. Yep, so that was about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we're like on number 12 right now. Okay. All right. Okay. So that's going to load us. We're going to learn where these numbers came from right here. We're going to do that right now. It doesn't explain that at all in this tutorial. It doesn't. It's just like, hey, do you recognize these numbers? It doesn't even say that. It just says numbers. And you're supposed to figure it out. You're supposed to figure it out. Hey, Trending, good to see you. Welcome on back. Like improved Python indentation. Ooh, David Bailey. Yes, the improved indentation. A little bit cleaner there. So it's a little bit easier to read. This is what I like to do. I like to do that. Make it pretty. Awesome. Thanks for sharing. You're welcome. Do you use TensorFlow? Yes, I have TensorFlow saved here. There is a OCR, optical character recognition, with the MNIST on the Keras. Keras, if you're going to be using TensorFlow, use Keras. However, my understanding is TensorFlow is kind of the older technology. You want to use Google JAX. Google JAX, I think, right? Is that the new one? JAX is an open source Python library developed by Google Research for high performance numerical computing and machine learning. For AI, combines familiar NumPy-like API, powerful features, and automatic differentiation, and a JIT compilation. So it makes it even faster than all the other things we're doing, right? And that is what you want. You want JAX. So we'll probably move on to JAX after we become experts in Pytorch. Most research papers use Pytorch. Pytorch is great because it's got that same exact NumPy-like API built directly into Pytorch, which I love so much. It's my favorite. Oh, I love it because you can take two tensors and then run math operations on them and it will know exactly what to do. Whether you're doing a matrix mult or a dot product or a reverse dot product. Times FM use JAX, right? Oh, they do? I didn't know, Shadow King. The more we know. That's great to know. That's great to hear. How do people figure all this out? I thought installing running Conda and RDKit and running tests in VS Code was wild. So much learning. Yeah, there's a lot to learn. There's many eons worth of learning that will be so challenging to win all of it. Yeah, thanks for the hearts, you guys. Halo uses TensorFlow. That's why I started using it and have to check out JAX. Yeah, JAX is like the next evolution. It kind of took inspirations from Pytorch and a little bit of Keras and a little bit of TensorFlow, and they put it into JAX. And JAX. Before, JAX was actually just like a little annotation accelerator, and they turned it into a whole framework. Does JAX have all of the CNN and deep learning functions? They sure do. It's a full model. Declan Craig, good to see you, Declan Craig. Welcome back. Good to have you here. All right. Hey, would you be interested in a research paper or other collaborative work? Sure. GCA, I'd be down for that. I think we can have a lot of fun with that. Let's do that. Join the Discord and send a direct message. We could chat more. Okay. So we concatenated our stack. That looks good. Now let's calculate our numbers. Torch.std, and we say x, comma. What do we need? We need to do a little bit more than that. Dimensions. All right. Dim equals 0, 2, 3. All right, like that. And we do the same with the mean. Do we say mean like that? I think it's exactly the same thing, right? Yeah. Yes, mean and exactly the same. Okay, let's print those out. Print. We'll do a printf here. We'll do a printf, an f print. So this will be std equals, and then we will do the same thing with our mean. Here, okay. Mean, there we go. Now if we run this, we should see those exact same numbers. What do you mean, welcome back? Declan Craig, you've been here before. You do math? Yeah, we're doing math. We're doing AI math is what we're doing. That's what we're doing. Are you willing to do some interview prep or mocking interview? Long shot. Sure, Michael, tell me more. If you're happy to jump on an interview anytime. I've learned a lot from this page. I appreciate your easy to follow explanations as well, Stephen A. Dakota, thank you. That's great to hear. You felt lost a few times on the new coding journey. You gave me hope. This old dog can still code, yeah. We'll be old together, you guys. I'm in my 40s, and we're still learning. I'm in my 40s. We've been doing this for decades. Wow, thanks, LDM. All right, Michael, sounds good. Send those direct messages. Thank you for the hearts, you guys. All right, let's keep going. All right, so let's print this out. We should see on our screen a very pretty set of arrays that we want, although, whoops, we got an error. All right, line 70. Right here, the problem. Okay, did we typo something? Did we do something wrong? Yeah, sample 0 for SNS, concat data, train set. Oh, this is what we need to do right here. We forgot to add a dimension. That's usually one of the problems. You got to add a dimension. Whoops. And the way to add a dimension is by adding extra brackets like that. So there's another dimension. And then we added another dimension, right? You just keep doing that and you keep adding dimensions. Undo. Okay, let's run it now. Now we should see our pretty numbers. Oh, just kidding. All right, we still have a problem. La la la. All right, stack argument tensors. C star. Oh, we've got more data here. Okay. Yeah, I told you. All right. Okay. Oh, we're doing some list comprehension here. Okay, so now we've got a list comp. I forgot to add the list comprehension stuff. Okay. That one is not a Pytorch exclusive thing. List comprehension is just this particular part here. So you see you got an array, and then you can say something like another array here, like that, right? And so this will be your list comprehension. So we're doing some work on each of the elements inside is another array. So that's what that's about. Okay. Now we should be good, right? Yeah, no, we're doing good. Yay, there it is right there. Okay, perfect. All right, these numbers should perfectly match our numbers up here. All right, let's find out. What we should be doing is we should pre-calculate and then put these numbers in dynamically. That would be really neat, right? Should we do that? Hey, buddy, what's going on? It looks great. Go cool. Good to see you. We are continuing our Pytorch expertise journey. We're going to become Pytorch experts on this channel. Join me together. Let's do this. For each could never. I know, right? David Bailey? Exactly. Who has anything on for each now that you've got list comprehension in Pytorch? Or in Python, right? So, let's see. Are these numbers exactly right? Did we get them right? Do they look right? They sure do. Wait. Yep. What about this one? How about this one right here? All right, that one. Yep, right there. Yep, they match up right there. Look at that. Oh, they're looking good, you guys. Hey, man, Claude entered the chat. How are you going? Hey, Claude, good to see you. We're continuing our Pytorch journey, becoming experts. And we just discovered the source of those fun numbers that you might see floating around when you normalize datasets. Look at that. If you have ever seen normalization coming out to you before, and you wondered how they got to those numbers, that's how you do it. Noob question probably. Is there a difference between Pytorch and Python? Yes. Cathix, yes. So Python is the language. Python equals language, right? Equals the programming language. Equals programming language. And then Pytorch equals framework for Python to build AI models. Pytorch, and I didn't spell. All right, so let me spell it out a little bit more for you. Pytorch is also a C library. It's a C++ library that has bindings that work into the Python language that allows you to call this compiled, very fast and efficient C++ code directly in Python. That's the Pytorch part. So it's got an underlying high-performance library that you can use in a nice, fun, easy language like Python. Thank you for the hearts, you guys. Appreciate it. Okay, let's keep on going. So this gives us... How about we do a fun thing? How about we manually calculate these numbers when we generate our transform composition inside our LeNet directly? You might not have to do it like this, but we're going to do it anyway. We're going to do this anyway. All right, let's do this. We're going to create a new function now. Def norms, normvex self, and we're going to put this code here, right here, you guys. We should also grab the training set. Perfect. Okay. Look. Wait. No. No. Almost. How is it possible to run the C code in Python? It's actually a library that's so it's already compiled, and your Python runs through either an FFI, so foreign function interface, that allows you to call code from that compiled library. It gives you access to function tables, which have memory addresses or code execution addresses that allow you to pass in data pointers and registers. That has a nice little sort of interface when you call functions. And you learn assembly language, essentially. When you call a function, you put data into registers, into CPU registers, and those registers will be able to be used inside your C code. So you can say, in Python, you put some functions in, some variables into some functions, right? So you've got this input variable right here, like the input variable right here. That will be stored as a pointer reference to the data inside of one of the registers. And then you can use FFI to call a function that has been already pre-compiled in C and reference the register. It's all C eventually, David Bailey. You got it. Exactly. Thank you for the hearts, you guys. Good to have you here. Happy Tuesday. All right, let's pull this in here. So we are going to return. I think what we should do is we should return this normalization function is what we should do. Let's just straight up return this. I think that will be much better. Norm vectors, yeah. All right, so we'll say return. Return. So we're going to above and beyond our demo tutorial. We're going to add a little bit more to it. We're adding a smidge more into it. Okay, so X. I'm going to call this out really quick. I like calling it out instead of X because it's the output. Return, and we're going to say the mean, and so it's going to be mean and standard deviation. Okay, so say mean and STD, like that, just like that, right? Boom, right there. Perfect. Yeah, like that. Okay. Cool. The Rust runs in the same way like Python. Yes, exactly. You could do the exact same. Mohammed, thank you for saying hello. Good to see you. Happy Tuesday. We're going above and beyond the tutorial. We're baking in some of these numbers. So I can say, I do believe I can say now, like this, self.norm vectors. There we go. Let's execute that and make ourselves all sorts of happy. All sorts of happy now. Hey, thank you for the laughing disco. 250 joules. Is it Dan or Dennis? Denisech, thank you. My gratitudes to you. I was not expecting that. Thank you. If you quick, I am keep cool. All right, Sujat. Music official. If you quick. What do you mean? What do you mean? I don't know what you mean there. This should be that. Okay, there. Perfect. Do we need... Am I missing something now? Am I missing something? Or did we do it proper? Thank you for the hearts, you guys. Appreciate it. I think we did it all good. Let me double check. I want to make sure. La la la. Yeah, those are two tuples. Like that. And they're norm vector. Okay. All right, looks good. Norm vex. Right there we are. Nice. There we go. We're looking good now. We built it all in. We sure did. Let me do this real quick, just for commenting's sake. Hold on, let me bring these back real quick so that way we know. I'm gonna grab these guys. I'm gonna put those in the comments. Okay, right there. Boop, boop, boop. Okay, like that. So that way we know. We know what this is. Now we know what that's about. Please let us use NASM language. What's the NASM language? I don't know what that is. There's so many things. Was that a typo or is that actually a thing? Or are you saying NIM? Are you saying WASM? Those are really close things. Although WASM's not really a language. It's just a runtime container. Okay. Norm vex to tensor. Looking good. Let's run it. Let's make sure we're looking good, you guys. So I want to print out self. Let's do LeNet.transform. Let's make sure this looks good. So print LeNet.transform, I believe. Yes, that should do it right there. Okay. Let's make sure we got it right. Let's see if we got it good. Assembly language. Oh, it is assembly. Oh, assembly language. Not WebAssembly, assembly. Please let us see assembly language. Absolutely. So we've done some basics on assembly language before, which is, one step above machine language for the most part, right? We got our norms looking good. It's mean and standard deviation right there. Oh, looks so good. Is that the proper? Is that proper? Did we do this correctly? This looks weird. Hold on. Wait. Maybe that is. Maybe that's the way it works. All right, we'll deal with it later if it's broken. Hello, stranger, and everyone watching. The stranger. How have you all been? Take care of yourself. Eat 3 meals a day and get plenty of sleep. Oh yeah, reminder that you are loved. Have a great day. Hey, Echo, thank you. It's really nice for you to say. Appreciate it. You're inspiring going to work on my project whilst learning. Hey, yeah. It's a lot of fun. That's why we're doing this. That's a lot of fun, you guys. Okay, let's keep going. We're not done yet. Okay, let's get back to our tutorial. We just went through this part of the picture. I like this song. It's my favorite song. This song goes, okay. So we are going to load our data, which we have. Ooh, train data, batch size, shuffle true number of workers. Oh, we need a loader. We're going to grab the loader now. Okay. What would be great is if we could also load this self dot. Let's do this. So that way we have it. Equals. There we go. Okay. Are you making a switch function of torchlight? A switch function? This is just very basic Pytorch stuff. I don't know what to say. Torch. This is Python Torch libtorch library. It is an AI machine learning library, and it's going to allow us to classify image sets. This is what we're currently working on, an image classification model called a convolutional neural network. Okay. I think we're good now. Got that there, looks good. Just double checking things. Got our norm vex. We should be happy to go. Oh, right. So we got our test data. Also, load data. Let's do that. We'll say transform train set. We want train set. Train set equals. Hold on. Wait. We have to go back to my favorite song. Hold on a second. All right, train set. So let's continue with this part. So we are going to grab this from our load data right here. Self.load data. Okay. Looking good now. Happy with that. Clean, simple. Don't need this anymore. I suppose we could return it, although we don't. Wait, yes, we should probably, yeah, we'll return it. Return self.trainset. Train set, please. Yes, thank you. Okay. If then we say return. We're going to prevent us. Here's what we're doing. We're preventing ourselves from double loading the data because we only want to load it once. We don't need to load it more than once. We only need the train set once. Just one time, you guys. La 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 la. Okay. We might be going early optimization on this. I'm okay with that because it's very light touch on the early optimization. Okay. Where are we doing on time? We're doing good on time. All right. Let me double check because I want to make sure I do have a meeting coming up here that I got to take care of. And I want to validate that we're good on time. Yeah, we're good on time. All right, we're good. How's it going there? And Anzi, am I saying your name right? Anzi2455. Good to see you. Thank you for joining in. Okay. Train set. And then what we should do is say self dot train set equals none. Initialize it to empty. Training data set. There we go. Like that. Okay, let's keep going. Okay, and that's great. A data loader. We're going to run that in our model as well. We need to grab that somewhere. Where are we going to grab that, you guys? How do you say that? Anzi, thank you for subscribing. Appreciate it. Oh, really nice for you to do that. Thank you very much. Welcome on in. You joined the right channel for software engineering. We're going to be building a convolutional neural network today, and we're going to be training it today. I do believe we have enough time. We have enough time to train it. So let's make it happen. We're loading in the data right now, and then we're going to train it. Where is my data loader? Do I want that? I want that there. And there's my train set self dot date. We're going to call this train loader. I'll say data loader equals none, like that. And then we're going to snag this when we load the data, self dot data loader. We're going to put it here. Torch you choose data loader. Right? Torch.utils.data loader. And we're going to say self.train set. Like that. And we're going to make it look pretty. Okay, we need batch, shuffle, and number of workers. Batch size equals... You went 4? All right, we could do 4. We could go more than 4. We should probably do more than 4, really. Let's go some hyper parameters. We're going to go self.batch size, self epochs. We'll go 10 maybe. And we'll say 4 for now. Self.learning rate. Something simple like that. Maybe we'll do this. We'll make it right there. All right. Yeah, you seem to be really lost. Please learn from some basic Python programming at least. It'll be a little bit easier to follow through these live sessions. Can refer you to Chia Code or Shradia, DD Python. Those sound like good recommendations. Okay. Shuffle number workers. Did we do that all? Did we do that yet? We didn't do shuffle equals true. And num workers equals 2. There we go. As someone from the hood, I have no idea what's happening here. DGAF, good to see you. How you even grasp half of this. It takes a while. It does. Don't get me wrong. The goal is what you're going to do is you're going to just type everything out, kind of like what we're doing, and it's okay not to understand it. It takes a while. It might take weeks. It might take months. Eventually, you'll start recognizing patterns. And you're like, oh, wait, I saw that thing over there. Oh, wait, there's that one thing. And then there's that other thing. Oh, there are other things over there. And it starts building on itself. Your brain, it gets going. It gets going. And you connect all your neurons. And eventually, it starts making sense. It just takes a little bit of practice. How you building a network? You didn't test each environment. Your mind is same as Tesla. Oh, I don't know. Well, in this case, we're just using a framework, so we're kind of cheating a little bit. A little bit cheating. Thank you for the hearts, you guys. Thank you for being good sport about my insolence. Good, liked and sub. Oh, thank you, DGA. Appreciate it. Good to have you join in. Let's become experts in software engineering together. Let's do it. Epic Blocks, Bo, good to see ya. Welcome on and thank you for saying hello. Love the positivity, man. Have you ever programmed in Zig? I've used a smidgen of Zig. A smidgen. I could do a bit more Zig in my life and be happy about it. I think Zig would be great. We'll be doing more languages on this channel. The plan is we're going to go through a lot of software engineering. Right now, AI is all the thing, isn't it? Shouldn't we learn how this stuff works? You know C++ or Java? Absolutely. Zig or Zen. I know of Zig. I don't know what Zen is. I don't know what Zen is. What is Zen? Zig is a programming language. Zen sounds like some real world product. Hi, bro. Saz, good to see you, Saz. Welcome back. Good to have you here. So yes on C++, yes on Java. I tend to stay away from Java because it makes me not happy. I don't want to do it. Like Java, no, please don't make me do Java. Although good news, we've got AI now. The AI can write the Java for me, so I don't have to do it anymore. Zen is like oh, got it. It's a synthetic, understood. It looks like Altoids. I was wondering. All right, let's keep going, you guys. So we got our data loader. And we're returning a data set. We don't need to, this is fine. This is odd structure. Don't follow this directly because we're doing some weird things here. It's okay though, it's okay. We're just trying to encapsulate some things. It's not perfect, it's good enough. Yo, Steven, where do you apply to be a mod for your channel? Oh, right here. All right, let me click a button. 1 second. Add as moderator. There you go. Boom. GCA. Oh, Kyle, you're fine. Hey, good to see you, Kyle. Hey, Kyle. I upgraded the automatic AI video editor scripts, and I think you were talking about some of that. I do have some news for you. The numbers jumped after the editing improved. It did. The numbers jumped. They did. And we can go even further. We can make it even more interesting. And or we can go even further. Congrats. Yeah, we can do it. Yeah. And if you want, we can share. The only problem is if I share the code with you, it's specific for my workflow. So you'll have to, if you want it, it mostly won't, you'll have to do a lot of work to get it to work the way you want it to work. So it's safe to say that anyone who sees this for the first time would be confused and lost. Yeah, I think so. You're right. They probably would be. I knew you were doing something. Let me in on it. All right, Kyle. Sounds good. I've been looking at your shorts and I haven't seen any new posts recently, Kyle. I jumped back. I'm like, am I missing Kyle's posts? I'm like, no, you just haven't posted for a while. Hey, I started using VS Code with my Vim and you're a bit frustrated. Hey, it's okay because Vim, there's some things that you got to learn in Vim that make it a little tricky to learn. So it's understandable. Vim motions. If you want, there's something called Vim Tutor. Type Vim Tutor and it will walk you through all of the different Vim motions and keystrokes. Let me in on it, bro. Yeah, I would like to contribute to the automatic clipping script workflow. Ooh. Some of the things that I want to add into it. So I added in automatic Jiffy and Texel and they didn't meet my desires of quality. So I temporarily removed it. I also have some automatic like zoom in, change of camera angles and things like that. Nice. Watching from California. Oh, DGF. I live in San Francisco. I moved here to Seattle just recently. So I lived in San Francisco, California in the Soma district, south of Market. Film movie scene, Java. You human cannot defeat me. Human, Steven. Oh no, but I can then AI enters the scene. Man, like this. You mean like this? Yeah, exactly. Claude, hey, good to see ya. We don't need to type JavaScript or Java anymore. We can just use the AI. The AI will take care of it. All right, let's get going. So if you want to get your Vim motions, you can just use Vim Tutor. It was the story of that tangent. Okay, let's run this and make sure it's working. Okay, transform. Not defined. Sounds good. Do we mean transforms? No, I meant transform. I did mean transform. Where is that at? Self. Transform. Transforms. What line was that on? That was line 47. Okay, right here. Self. Oh. Okay, hold on. Okay, we got to do something different. We have to, instead of saying load data, we can't do it this way. We have to do something different. Okay. I found a bug, you guys. I found a bug. We can't do it this way. It won't work. Okay. So we can do load data, although we can't do it exactly like this. So we're going to have to change this up again. We have to do it different. So we need to bring this back over here. Like this. Okay. How do you like it up here? Oh, in Seattle? I live in Seattle now, and I like it. You know what? It's really not really the area so much as the type of area that I'm living in now is a suburb versus downtown San Francisco. It's a little bit different. That's awesome. You're across the Bay Bridge without too much self-doxing. Oh, yeah. So that is, what was on the other side over there? No, not San Jose. That's south. I know what you're talking about. It's that it's got its own airport. It's either you can choose SFO or the other airport, which was across the bridge. I forgot. It's been a year. Berkeley. Thank you. Berkeley. All right. Yeah, that's one. There's another city over there too, right? Not just Berkeley. I really want to see your channel grow. Hey, GCA, thank you. Appreciate it. That's what we're working on. We're making that happen. All right, so we're going to put the data loader up here, and we're going to do something different. We're going to keep that here. And okay, no, we're good there. Whoa, Kyle, real-time API pioneer, brilliant software architect, and an all-around legend. Thanks to everything you built, Steven. Appreciate it. Kyle, thank you. $10. I need to create a ledger is what I got to do. Kyle, thank you. That was amazing. I was unexpected. $10. What are you doing over there? Let me click a reply on that. Wow, thank you. Wow, thank you. Exclamation point, party popper. I gotta do at least one party popper. How about we do several party poppers? Hey, Kyle, thank you. That was amazing. $10. I'm gonna, what? I need to keep track of this somehow. Oh, you know what? YouTube already does that for me. All I have to do is go back and see every single thing that you've done. And don't worry, Kyle, I'm gonna remember. Right on, Kyle, yeah. It's like 20 cities clustered together, yep. San Francisco hot dog vendors sell hot dogs for $10. Ooh, that's right, they sure do. I remember looking out my window, I could see the hot dog vendors. They were always there, and party nights. They were usually there might be two. There might have been two. Sometime coder get feeling like AI is making only for defeat, right? Coding language is the matrix theory. Wait, hold on, Claude. Hold on a second. Let me reread what you just said because I don't get it. Kyle, thank you again. I appreciate it. I just jumped back over to Kyle. That was great. Okay. Sometime coder get feeling like AI is making for only defeat tough coding languages. So this is matrix theory. Good point. We could be in a matrix. We could be in a simulation. The AI could be making very difficult coding challenges, make difficult languages, so that way humans can't keep up. Is that kind of what you're saying? I kind of think that's what you're saying. All right, let me get the norm vectors. We don't want a loader here. We don't need train set anymore, so we're just going to do this. There we go. Like that. All right, perfect. Okay, so that is going to give us norm vectors directly. Have what I considered a very important question, Stephen. Do you have an iPhone or Android? It's an Android. It's an Android. I use the Android, you guys. I like it better. It's fast. It's very fast. And every time they release new operating system updates, it doesn't slow it down. Mac and Apple, stop slowing down your hardware every time you release hardware and software updates. It's the most annoying thing. I used to have some really good, very fast systems that they just slowed down with every subsequent update. I have a very, very old laptop that is like 15 years old, and it runs faster than the Mac hardware that is only a few years old. It's ridiculous. They are absolutely degrading the speed and performance of their hardware. It's true because I've got empirical evidence. I knew it. The smartest people use Androids. Hey, nice. Which Android phone? This is OnePlus. No offense. Don't care if you keep track, Stephen. I authentically get inspired. Maybe this is emotional music talking. Hey, that's great to hear. Thank you. To use Google Pixel is great. Google Pixel is great. I use a OnePlus. I think a Pixel would be a good upgrade at some point. So like AI is for human coding language. Work make easy. Well, I guess it does make it easy. It sure does. Are we getting too smart? So the matrix, the AI, it's saying, hey, you're getting too smart, human. We're going to dumb you down. We're going to make it too easy for you to write code so that way you don't get any smarter. React apps and Python. Nice. I like those React apps. Okay, so let me keep going here. Did anybody here have a BlackBerry at some point? I was around Blackberries, but they were too fancy for me. They were too fancy. I had a Nokia, like a Nokia phone. A Nokia. That's what I had. And I didn't have a smart device until I moved to San Francisco. Do you remember those Palm Pilots? Do you remember Palm Pilots? Are you and I that old that you remember the Palm Pilots with the stylus? Okay, I think we're good here, guys. Okay. I thank you for the hearts, you guys. Appreciate it. The party poppers. I think we're good to go here. So we're going to load our data. We don't really need this. And this is going to be different. We don't need that. We need self.transform because we've done up here. All right. Data loader, train set. So that grabs this here. We don't need to return that. We're just going to load the data. So let's do that here. Self.load. Okay, good. Yes, and I missed sidekick. Oh, really? Yeah. Oh, wow. Okay, yeah. So we're both old enough to remember those things. Heavenly, good to see ya. Nice. Heavenly Demon, you guys. Heavenly Demon, welcome on in. All right, I want to make sure this is good. All right, what is our time? All right, so we got 35 minutes, you guys. We've got time. We've got 35 minutes. We're gonna make it. We're gonna make it. Okay. Let me run this, make sure it looks good. Are we missing something here? All right, line number 45. 45. Right here. No. 45. Yeah, right here. Okay. That should be... Oh, we did it. Okay, so we have to do this here. Okay. All right. I suppose what we could do is we could run this... We could put this over here because it's all the same thing, right? So we can put this all together. So make that a little bit easier. All right. Load data and vectorize. Create transform for vectorize. Okay, perfect. Steven, yes. So like AI is for human coding language, work make easy. Still don't get it. I still don't get it. Are you using Linux right now? We are using a Unix variation called Darwin. So you name right here. You can see I'm using Darwin. If that shows up on your screen, it's just Darwin. So it's D-A-R-W-I-N, which just means Mac OS. That's all that means. I'm making it sound fancy. Do you teach coding? At what coding language do you know? We know a lot of coding languages. We know our languages here. We know languages. We know... Let's see, let's paste it in. All right, so we know Rust. We know C. We know PHP. We know JavaScript. These are the ones that I know the best. Like, I actually know these languages really well. JavaScript. There we go. We know Python, which is what we're using right now. And then what other languages do... These are my main languages. Let's just say these are my main primary languages right here. C/C++. Oh, C#. That's another one. C#. Completely different language. We do know Java, but I don't know about Java. I'm not sure about that. Rank them, number list. All right. So I would say I would go like this. C#. C. Java's like down here. Java's way down at the bottom. Okay. PHP. I know others. Oh, Perl. And I would put Perl above PHP. I guess because it's a preference, it's a choice. Is Opera a code language? Opera is a browser, isn't it? Numbered lists. One. There you go, numbered list. There you go. 2, 3, 4, 5, 6, 7. And Java is 1 million right there. I wasn't talking smack to a Java government dev the other day. You weren't? 1 C. Hey, Alto Labs. Yeah, C. C is really great. I like C. And then maybe like, I don't know. I know of assembly, but I wouldn't necessarily make it on the list. I'm just mentioning it. It's just a mention. So I'd put that here. Assembly. Yes, but thought it might be both. Oh, both of them? Oh, okay. I'm not sure about Opera being a coding language. I do not know if it is or not. Bro, you made big relatable theory, but there is some point in your matrix theory, man. Is there? Okay, I think that counts. Are you old enough to remember MySpace? Yes, I am. I had a MySpace account. I was friends with Tom. Was it Tom from MySpace? I was friends with Tom. Have you tried your hands on embedded stuff? Yes, absolutely. PIP30, ESP32. So was that Arduino, and a couple of others that were others like basic standard microprocessors. I've done that before. I've done some of that with some C. These are my main languages. I know others. We've done a little bit of NIM. We've done a little bit of Erlang. We've done... We've done some zig, a little bit of zig, just a smidgen of zig. Like, no bare metal coding. A little bit of bare metal coding, yes. A little bit. I'm trying to learn GML. I don't know what that is. Hey, Funky Infused! Funky Infused, what is GML? Forced internship friends in a wild hindsight. Forced internet friendships. Oh, forced internet friendships is wild, is it? How are you forcing internet friends? I don't know about that. Have you ever tried Qt in C++? I have, and the dependency chain is a challenge. But just to put it in a little bit of a perspective there, Qt with C++, I had such struggle trying to build that. I've run into it before, and it's been tough. You had to be friends with Tom from MySpace. Oh, right. Everyone has to be friends with him. Yeah, exactly. It was a forced friendship. Kyle, you remember it? Yeah. Oh, you remember that, Kyle? Yeah. It was a forced friendship. Okay. So those are our languages. We're going to delete that for now. We're going to see if we can fix our code here. All right. Okay. Let's see if we got that working. Nope. Where are we at here? Line 61. Okay. Train dataset transforms. Self.transforms. Transform. Ah. It's right there. Right there, you guys. It's right there. This is perfectly fine. Right here. Why is that not good? Ooh, the game maker language. Oh, yes, the game maker. I know about that. I've never used it, though. Shout out to Kyle. Yeah, absolutely. Good memory, Kyle. Good memory. Okay. LeNet object has no attribute transforms. Transform. It does because I gave it one. I gave it one. Do we have that here? Do we say self? Yes. Self.transform is right there. How about this? We'll just do this. We'll make it a little bit easier. Okay, how about that? Oh, is that better? We got rid of it, line 61. 61, GG. Ah, here we go. Okay, that's what, all right. Now we're good. Can I bring it back? Hey, look at that, no more errors. Hey, all right, progress. Okay, so now we've loaded our data. We've loaded our data set, and we got our data loader, and we got our transform. Hey, we're making progress, you guys. Man, are you getting bored by your theories, man? If you find interesting and point out your theory, also for comments, man. If I can understand what you're saying, I don't know. For the most part, I'm doing my best. I do think they're fun, though. Yes, Kyle, good memories. Don't even get me started about the MSN Messenger and AOL days. Do you remember ICQ as well? Do you remember ICQ? We're bringing stuff back now. Thank you, man. You're welcome, Claude. Absolutely. Okay. I think I can bring self back here. I think I can. I think I can, right? I better be able to. I'd be surprised if I wasn't be able to. All right, good. Okay. We're going to do that because I want to. So I wanted it to be that way in the first place. Yeah, ICQ, yeah. All right. So now it only took an hour to get past this line right here because we got a little bit distracted. All right, so here's our classes. I'm going to just copy and paste that. Self.classes. Where? No, we should say number of classes. There we go. Okay. So those are our parameters there. Hey, how's it going there? Broken Robot, thank you for following me over there on the purple platform. Good to see you there. Hey, purple platform, you guys. Thank you for the follow. Thank you. All right. Thank you for follow. Exclamation point. Okay. Also, music match what you said about time is running out of your stream. Yeah, I know it got a little bit of urgency here, you guys. We've got 25 minutes, so we're good. We're going to get it. We're going to train the model before the end of the stream. Here go, my 25th like. Hey, Claude, thank you. So those are classes. Do we have outputs? Where's that at? Classes, here we go. All right. So this needs to change. I would actually, you know what? Let's do this. We'll bring this up here. Like that. All right. num classes is going to be here. And we're going to say len classes, like that. Okay, perfect. Plane, car, bird, cat, deer, dog, frog, horse, ship, truck. We're gonna have all these different images that are available to us. These are our parameters. Man, meet you tomorrow. All right, sounds good, Claude. Good to see you. We're gonna keep on going with the convolutional neural network. We're gonna be training our model very soon, very shortly here. In fact, let's do a show image really quick on our data set. Numpy plot. Let's import the matplotlib real quick. Okay. Import matplotlib as PLT, right? Matplotlib pyplot. Pyplot, P-L-O-T, as PLT. And then Numpy, import Numpy as NP. Okay. Great stream. Hey, Sergio, thank you. Appreciate it. Good to have you here. All right, so we're going to do the show image, unnormalize. Okay, let's just waste some compute. Let's waste some electrons. Image, unnormalize, image.numpy. Okay, let's write that function real quick. We'll do this down here. Def, you know what? Why don't we write it here in the class? Let's write it here in the class. Def show image self. Okay, and we'll just do one. We'll do one image. One image. img equals. We need to grab the image from somewhere. Where is that going to be called? Data loader. Where's the show image? All right, make grid. Okay. Image equals something. And then we're going to say np image equals numpy. img.numpy. Okay. If we want to do that, we sure do that. Plot show image np.transpose plt.show image np.transpose. Why do I have to do transpose like that? Why can't I just do .t? All right. np image. No. np image, comma. And then 1, 2, 0. Okay. Do we do, that's it right there? We don't need to say a plot.show. We just straight up do that. Is there anything else? Okay. Oh, look at that. We're going to get a grid of 4. Okay. So that's what we're doing. Okay. Got it. Okay. Make a grid. So we're going to grab some of the images. One batch of images. Okay. So this will be a batch of 4. Got it. This is Sneaking Coder, mission 20. Yeah, T-minus 10 minutes to fix the code or we'll be screwed. I know we got very little time, you guys. Wait, we're gonna make it happen though, don't worry. I need to load that from our data iterator. All right, let's do this. I'm just gonna say iterator equals iter and our train loader, so self dot, what do we call this? Data loader, right here. Okay. All right, we got an iterator. Then we got the la. Oh, and then we need to grab some of the data. All right, so we're gonna have images, comma labels. We're going to say next iterator. Okay. And now we could just do this. Images like that. There you go. Just like that. Easy peasy. Easy peasy. Hey, thank you for subscribing. Nap Howard. I think I don't know how to say your name though. Appreciate you joining in. Glad to have you here. Happy Tuesday. Let's become Pytorch experts together, you guys. Let's make it work. I think we can do it. I think we can succeed here. So we've got a show image. Let's make sure we don't have any syntax errors. All right. Looks like we do. Looks like we're good to go. Oh, nope. Just kidding. There always has to be something, doesn't there? All right, density, linear 3. Oh, wait, why is that all of a sudden a problem? That shouldn't be a problem. All right, empty received an invalid combination of arguments, got tuple. but expected one of what line? Line 109? 109, you say? Okay. All right, 109, GG. No, that should be fine. Hold on. Here. Let's just comment everything out until it starts working again. Okay. So we definitely could not have solved anything without that comment that we just did. All right, line 109, and then go up to, density. Got it. All right, so I moved some stuff around. So it's not classes anymore. It's called number of classes. All right. So self-density, and then we're going to have num classes. Okay, classes, num classes. All right, so this is going to be self.num classes now. We don't need density. Yeah, we'll keep density. Okay, so here's the problem. We can fix that. It's right there. That one's easy. That one's easy. Not a problem. Not a problem. Okay, that should have done it right there. All right, good to go. Good to go. Hey, all right, perfect. Okay. Happiness is around the corner, you guys. Let's align these to make them prettier. All right. Get a little distracted at things. All right, so now we can uncomment this. And we are going to simplify by doing this, I believe. You know, we'll leave it there for now. All right, so we got to thank you for the heart, you guys. Hey, how's it going there? Hey, Juan Carlos. Hey, Juan Carlos, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're going to be learning Pytorch. In fact, we're going to learn so much Pytorch that we will be becoming Pytorch experts. Let's become Pytorch experts together. I put something pretty interesting in general chat if you want to review it. Yes, Kyle, absolutely. We have to, especially after all those amazing donations. What do you got here? Oh, hey, Metal Gear Solid. AI prediction. Check out this creative spin on culture and AI. Okay, is it a video? All right.
Raiden, are you having fun playing with the new AI toys?
Well, yeah, I am. You can make pictures of cute anime girls.
Enjoy it while it lasts, Raiden.
What do you mean?
Did you really think that civilians would be granted unrestricted access to such powerful military weapons forever?
Military weapons. Are you implying that this technology was created by the government?
Of course it was. This AI technology has been used by the intelligence agencies to warp the public's perception of reality for years. All in the name of national security, of course.
I don't
Why
know.
would they suddenly make the tech public and let everyone start using it?
Why would we indeed, Raiden?
What in the hell are you?
Your question is irrelevant. By creating a new problem, we can cultivate a desired reaction to it in order to manufacture consent for our preferred solutions. In short, it's justification for a war.
We could justify war without AI.
A war on misinformation. By arming the public with these AI weapons, everyone becomes a potential enemy combatant. Then
So SQ Lighter, we're watching something that Kyle posted in general on Discord. It is an AI video make from Metal Gear Solid using some of the characters and the voices. And it's a little weird. I don't know. I mean, there's some like conspiracy. I mean, the whole point of Metal Gear Solid in general, like the foundation of the story was heavily conspiracy driven. There's some truth in there. There's a smidgen of truth, though right now there's a lot of conspiracy.
we'll have justification for unprecedented security measures. It all comes down to confusion and identity, Raiden.
Identity?
Identity. This AI technology is Pandora's box. Pretty soon the internet will be mired in total illusion.
Yeah,
Perfect AI speech, audio, and video synthesis will drown out reality.
that's fine.
AI bots will flood social media. No one will be able to tell the difference between interacting with an
No, we
AI
can.
machine
We can already tell. There's a way to do it. Misinformation already. It's misinformation right now.
That is when we will present our solution. Mandatory digital identity verification for all humans at all times. The only way to ensure that you're dealing with a real flesh and blood human being and not an AI generated.
No, misinformation. We already can tell. We've got ways to do
For
it.
too long, the internet has acted as a double-edged sword.
See, it's already
User activity allows anyone at all to spread any thoughts, ideas, or information patterns that they please with impunity. State secrets, dangerous ideas, ludicrous conspiracy theories. misinformation, and disinformation. Until now, there has been no easy solution to this problem. Our digital identity platform will finally put an end to anonymity online. It will allow us to trace misinformation.
That's already happening. It's already happening. You don't need to worry about that. It's too late.
That's crap. I won't go along with it, and others will resist.
You won't have a choice, Raiden. Do you think your bank is willing to risk doing business with an artificial human instead of a real one?
Yeah, I think that might happen.
Our identity platform will be required not only to access web services, but to pay for your internet connection in the first place.
You can't just censor the entire internet because of a new software technology.
We don't have to. Guys, don't worry. This is not a thing. It's not a thing. Don't worry. We already can tell. It's not a problem.
Fakes you've been making of me, Raiden.
I don't even remember how I found your channel. Oh, SQ Lighter. Hey, SQ Lighter. Your name reminds me of Moonlighter, that game. That was a really good game.
We will create context for its use. First, we will censor any use related to social taboos. Then we will censor anything else that we...
Hey, Jones, welcome on in. Good to have you here. Hey, Kyle, I can't watch anymore. It's misinformation. It's wrong. We can already tell AI. We can already tell what is AI. It's not a thing. It's not a thing. We don't have to worry about it. It's okay. It's okay. It's okay. Don't worry. Don't worry, you guys. We've got a trick. I just thought it was creative. It's actually pretty creative, and especially since it was built with AI, and it's kind of like meta describing itself, like with misinformation. It's like the internet's gonna be filled with misinformation as it generates misinformation itself. I know, it's pretty crazy. Let's see here. I think my sister showed me that, and do you know Neva? Yeah, Neva. Oh, SQ Lighter, you're the sibling of Neva? SQ Lighter, no way. Are you serious? That's amazing. Hey! Oh, wow, that's awesome. All right, you guys, let's pop back to our code because now we only have 13 minutes to our code. I had to stop watching that guy. I couldn't take it anymore. I love Metal Gear Solid. Don't get me wrong. That was a fantastic game. I played it hours and hours. Hideo Kojima did major research for that game. For MSG, was really well studied, though. It was a great game, and all the follow-up sequels are really great. The average person can't tell, though. It's okay, Sayloth. It's okay, Sayloth. That's true. It's okay. We're gonna annotate it. We'll annotate it. Hey, how's it going there? Basketball for Life. Welcome on in. Thank you for joining the channel. Appreciate it. This is a software engineering channel where you're gonna talk about AI and artificial intelligence. What's your opinion on synthetic data sets like images and synthetic AI generated objects outside the trained object and recognition on the model? Oh, Beanos. Okay, that's actually great. Having synthetic data is really powerful. It's going to give you the ability to generate information and build your model in a way that's going to be even more powerful. Synthetic data is huge. It's one of the ways that I've been able to improve a lot of my models. If I didn't have synthetic data sets, my models wouldn't be as good. Metal Gear software. We really don't need Steven Gaming Channel. Oh, Beanos, yeah. Maybe someday, but someday. I don't know to code, though I'm just watching because I'm currently making a meme on PubNub. I need information. Hey, SQ Lighter, that sounds great to me. Came to drop a like. Off to bed. Have fun, Steven. Mr. Dungwall, thank you for stopping by. Good to see you. All right, you guys, we got 10 minutes left now. We got 10 minutes. Don't worry, we're going to get it go. We're going to make it work. Did we fix it? All right, so we're good here. All right, you guys. So let's get the images to show up on the screen at the least. I want this part. I want to see this part right here. Let's see if we can make that happen. Show image, image show, make a grid. Okay, images. So we're gonna grab that and we're gonna put it up here too. That's what we're gonna do. Okay. Show image, data loader, iterate. Oh wait, Okay. Torch vision you choose make grid. Torch vision dot make grid? No, utils dot make grid with the images. Okay. Like this. Okay. Do we want to do that before or after? All right. So images as they pop in, and then we forgot to normalize it. Okay, we gotta normalize it. So, and then normalize. Images equals images divided by 2 plus 0.5 Denormalize. Gotta go. SQ Lighter, thank you for stopping on by. Good to have you here. Say hi to Neva. About a search bar in which you search something, it responds by either live search or from Yahoo module or a Gen AI key. Oh, thank you for the party poppers, you guys. Appreciate it. Good to have you here. What's your Discord server link? Jones, I missed your message. All right, Discord server. Let's grab that for you, Jones, if you're still here. All right. At Jones. There you go. Discord server just for you. Hello. Okay. Let's see if we can make our code work here, you guys. I want to at least show the pictures. If we can show the pictures, I would see that as a good step forward. So we need to run this function here. So we're going to do iterator, reiterate on our data iterator, and we're going to load the images, and then we're going to take that and then throw it into this first. Then we're loading the image. Then we're going to normalize it or unnormalize it. And then we're going to plot to show the image. Okay, just like that. Hey, Night Hunter Crazy. Good to see you. Welcome on in. We're building a convolutional neural network running through the Pytorch tutorials right now. We're going to become Pytorch experts. That's the plan, you guys. How do I do a skeletonation? Wait, skeletonization. Night Hunter Crazy. What? What is that? I don't know what that is. I've got an idea. I don't know what you're talking about. Okay, let's try this. So, LeNet dot show image. Show image. Do we have two versions of this? Hold on. Wait. Show. Oh, we got a problem. All right. Where's this at? Oh, no, that's actually okay. That's okay. Okay, we're good. In image processing. Oh, how do you show a skeleton in image processing? Oh, yeah. Okay, well, that's pretty straightforward. So you've probably seen a YouTube video going around where someone built sort of like what looked like X-ray vision. Like they put their fingers and they could see like the skeleton. So what they did was they created a computer vision model that's able to recognize your eyes and nose and mouth position and body position, sort of like, and then also finger position. And so they took the finger position, created a box and recognized where your skeleton would look, and then created an effect that looked like you were using X-ray. It's not actually X-ray. It just makes it look like X-ray. It's kind of neat. It's kind of a neat trick. It looks impressive. Okay, let's see if this works. Are we gonna get pretty images or are we gonna get a crash somewhere? I was pretty meticulous. Oh no, okay. Freeze not supported. All right, we're getting an error here. Where is the error? Wow, it's a big error. That's a really big error. All right, we're gonna have to figure this out. A lot of love from India. Thank you, Night Hunter Crazy. Appreciate it. Good to have you here. All right. Okay. All right. Oh, good. We're on the right track, you guys. So good to have you here. Okay. Good news. We're really close. Let's see if we can. I want to show the images. I want to see this. Let's see this. Ours are going to look different because they're randomly selected. Let's see where our problem is at. Okay. So let's go up here to our show image function. Where's that at here? Where'd it go? Here it is right here. Okay. Let's bring this here. Let's pull those out real quick. All right, let's run that. Make sure that we're good to go. This is how you debug. You comment out the lines until you find the problem. Okay, so there's something before that. So right here, let's comment everything out. What are we building? All right, so we are. So there is a problem. Where's that at? Hold on a second. Depth forward. Pass. There we go. So this is a convolutional neural network. Okay, so far so good. We are going through all the Pytorch tutorials, and we're going to become Pytorch experts. Once we've gone through all the tutorials and we've made them our own, we are going to build more models, and we're going to be building some real AI projects. It's going to be a lot of fun. We already went through week 1, and now we're on part 2. We're on part 2 now. So the problem appears to be here on the iterator. Really? On the iterator and the data loader? Where is this at? Here, torch data, batch size shuffle. Yeah, it's on the data loader. An attempt has been made to start a new process before current process finishes. Okay. So let's get rid of the number of workers. Where's that at? Num workers. Let's get rid of that. How about that? Let's see if that does the trick. Because, yeah, all right. Hey, look at that. All right. Delete that. We don't need that anymore. Using CV2, computer vision 2. Kind of late. Was playing some VR. Oh, Jinlu, good to see you. VR shooter. Nice. We are using Pytorch. Good question. So this is Pytorch computer vision. Yeah. Doing Pytorch computer vision, you guys. Okay. So that solved that problem. Let's bring it down a smidge here. Actually, let's see if we can get the whole thing. Because now that we solved that problem, there's a concurrency problem. Oh, okay. So, has no attribute show image. Okay, the plot. Did I type it wrong? All right, import matplotlib pyplot. Matplotlib pyplot as a plot. And then, okay, plt.showImage. Am I typing there? Oh, IMShow. Okay. So you just got, I'm typing it wrong. Okay, perfect. Okay. NP transpose, NP image 120. Okay, cool. All right, let's try it now. Let me do a quick recording of the video game I was playing. Sounds good. Accesses don't match. They don't, do they? So that's probably right there where the problem is on that very last line. Okay. All right, you guys, 6 minutes. Can we do it in 6 minutes? I think we might be able to. Okay, we're not done yet. So it had an issue here. Let's read this. All right, I'm just gonna copy and paste this. I really want this to work. Okay. Blah, 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 NP image looks good. Yeah, we copied it perfectly. We got it all aligned perfectly nice. All right. NP image, numpy image to image. We got to make a grid of the images. Print images dot shape. I think that's just like this right there. And then, oh, here we go. Okay, this is a problem right here. Okay. That's what we're doing. That's what the problem is. All right. We figured it out. You guys, just by looking at the screen. Okay. Yeah, let's make it pretty. Okay. Here we go, you guys. Here we go. Are we going to see pretty images now? We're got to clean some stuff up real quick. There we go. Okay. Now we're going to see pretty images. Okay. Oh, pretty images. Where's my pretty images? Why did it just close out? What happened? Well, at least it didn't crash that time. Why is this not working? Where are my pretty images at? Okay. Why is that not showing? PLT.IMS show. Nothing's showing up. Are we missing something? Do we say plot.show? PLT.show? We can do that. Did you play Resident Evil Requiem? Oh, Requiem! It's on my list. Hey! Look at what we just did, you guys. We succeeded. Boom! Right there. Look at that! We succeeded! Hey! What is this? That looks like a horse? That kind of looks like a deer. That looks like an airplane? Maybe this is a boat. This is a boat. Okay, that's a boat. We did it, you guys! Look! We got data to show on the screen! Why did it take us so long to do that? It's because this stuff is complex, right? There's some complexities to it. Yeah! We did it! Come and check it out! Let's get some more random. And look, there's a bug. Look there right here. Check this out. There's a bug in the tutorial. There's no PLT.show. It's a bug. We found a bug in the tutorial on the Pytorch website, right? This is Facebook. This is Meta. This is their technology on their website right there. There's a bug right there. We found a bug on the tutorial. How many bugs have we found so far in the tutorials? Quite a few, actually. We found quite a few. This is like bug number 4 or 5 at this point. Have you had a tutorial without a bug? So far, yes, we've had a couple of tutorials without a bug. A couple, just like a couple. Man, I hate how we can code now. Before our AI, I used to play with the whole lib till I understood, and now we use AI to fast track it. I love how good it feels when things work. Me too. It's so good. It's a whole new world. Congratulations. Thank you, Mario Srini. Mario Srini, appreciate it. Oh, you guys, we did it. All right. So let's print out our labels really quick so that way we know what things are looking like. So that way we should see the actual values represented in our photographs. And then we will call it. We will call it. We're good to go. Let's print out our labels. Let's do this. Okay. So print the class self. No. Labels. Let's go labels. Labels. Let's print out labels like that. Let's print them out like that. Okay. We'll see if we can align them. They might be integers. So we're going to, yeah, they are integers. All right, they're integers. All right. So we get a car, whatever number 3 is, a frog? And what's this? Is it another boat? I don't know. If you want to do something cool, do np.mean on axis 2. Wait, what? Zachary Hamilton? Zachary Hamilton, what do you mean? np mean on axis 2 for what? The image? Oh, to do that on the image. Okay. Mean axis equals 2. Like that? Yeah, okay. All right, let's find out. Let's see if the images look prettier. Is it gonna work? Is it gonna work? Is it gonna work? Oh no, we got an error. It doesn't like that. Axis does not match array. Okay. Let's try axis 1 then. 1. We'll try lowering the axis down a bit. It might draw lines. I think it's just gonna draw lines. Okay, didn't like that. How about axis 0? Okay. No, we're gonna get axis 0. I don't know. We're gonna find out. No, it doesn't even like. How about we don't do any axis? Like that. Wrong spot. Oh, wrong spot. Okay. 1 second. Out dimensions. Axis mean. Where to put this? On the. Tell me, Zachary. Tell me where to put this. While you do that, I'm going to grab my labels and we're going to do a self.classes. Okay, so we're going to load this and we're going to say label. So see L for wait, hold on. LN labels. There we go. Okay. And we do self classes like this. There we go. Much better. Instead of numbers, we're going to see the actual names for the classes now. Zachary Hamilton, tell me the correct spot to put it. Oh, wait. I'm going to delete that for now. Right there. X, thank you. Okay. All right, you guys. Let's check out. Let's see if we can see what the class... Oh, here we go. Now we got the answers. Okay. So we've got the answers now, you guys. Hey, look at that. All right, this is great. So we will be doing the training of the CNN tomorrow. We essentially just got everything else set up. We got the data loaded. We got the transformation for the data. We've got a deer, dog, deer, and bird. So that's a deer, a dog. Oh, it was a deer. Okay, and then a bird. Line before where you were trying. Okay. Sounds good to me. Line before where we were trying. Let's try it. Okay. So right here, we could do images before Numpy, maybe. Dot mean. Axis equals 2. We'll try it there. If that doesn't work, we'll try it on after Numpy. Okay. We'll try it right there. Okay. It might error out again. It might error. Yeah, it's another error. Okay. So let's try it after Numpy. Like that. Do it on NP images. Okay, got it. Right here. All right, now it's on NP images. That says axis don't match array. So is it real function? np.transpose. Oh. what we could do is not transpose it. We can just run it like that. Okay. Let's see if that works. Let's see what that does. See if we can get... Oh! Okay. I don't know if this is what you're looking for, but it sure looks pretty. Look at that. Okay. You just averaged out all the pixels. So you just turned everything into an average. There you go. All right. Zachary Hamilton. I know, right? Mario Srini. What, would you ever want to do this for any reason? Not really. Nope. You don't need to do that. Although we did find now add access to. Now add access to. What do you mean? How do you do that? Add access to. What do you mean? Plus 0. I don't know. What do you mean? What does it mean add access to? Ooh, definitely pretty. Definitely pretty, you guys. Okay. Where are we here? Okay. I am wrong. All right. No worries. No worries. All right, Zachary. So the plan for tomorrow, you guys, is we're 100 views. Hey, viewers. Hey, it's so good to have you guys here. It's great. We succeeded successfully in making things work the way we wanted it to work. We are moving forward with our convolutional neural network. We're going to become Pytorch experts. Join me, you guys. We're going to become Pytorch experts together. Subscribe. Yep, thank you, sir. Sayloth, thank you for subscribing. Welcome on in. Good to have you here. I haven't done this since my master's degree in AI. Hey, no worries. We're having fun now, aren't we? This is great. So good to have you guys here. We're going to become Pytorch experts. Keep on joining here on the stream. We will be going through every single Pytorch tutorial, and we're going to be building some really fun models after we go through everything. Loons, good to see you. Welcome on in. Good to see you again. All right, let me clean this up really quick. I'm going to clean this up. All right, so I'm going to blah, blah, blah here. I'm going to delete this, so we don't like that anymore. I was trying to get you to average the color of each pixel. Oh, well, we could do that. We could do that. We've essentially already done that. We have that here. So we've already averaged our pixels, right? So we've done that here. Where is that? Norm vectors here. This is where we've done it right here. This is our norm vectors. So we could do that right here. So, it's all good. We've already done that. We've done that. What IDE? Oh, Anasazi. This is Vim. This is the Vim IDE. 75 viewers. That was a record. Hey, Loons. Yeah. So good to have you guys here. Okay, so the plan is for tomorrow we're going to train. Mine says 87. Hey, crazy mess up. Good. Thanks for chatting. Okay, you guys, plan for tomorrow. We're going to be building a CNN and we're going to train it. So we built the CNN. Now we're going to do the training part. We got the data in the right shape that we wanted. And let me double check. Let me double check. Wait, don't go anywhere yet. Don't go anywhere. Hold on. Let's make sure it looks correct. Okay. Is this right? We got everything good? Oh, no. Oh, no. Where did we do it? We made, here, let me just undo everything. Right here. All right. Like that? Okay. All right, let's try that. Now we should be back to normal. We should be back to normal now. Okay, are we good to go? Yes. Hey, perfect. All right, perfect. All right, this is great. Let's zoom in. Can we zoom in? All right, that's good enough. All right, so this is, what are those things? What is that? All right, so we get a bird, a plane, a frog, and a dog. There are frogs. Do you have a Discord? Yes, Zachary Hamilton, I sure do. I'll paste that over to you here real quick. Let's paste that over to you at Zachary. There you go, Zachary. Just for you. All right, there were frogs. I was wondering about that. I'm like, that kind of looks like a frog, doesn't it? Is there really a frog? And there sure is. All right, you guys, thank you so much for joining. We'll be back tomorrow. We're going to train the AI tomorrow, and we're going to actually learn the model. I appreciate it. See you guys tomorrow. Bye, everybody. See you tomorrow. Join back tomorrow. We'll be back, and we'll be training the convolutional neural network. See you guys.